In size, Venus is almost the twin of the Earth, but its dense carbon dioxide atmosphere, sulfuric acid clouds, and furnace-like temperatures mean that this, our closest neighbor, will be one of the last to be visited by humans or even robots in the foreseeable future. The only place beyond Earth that both humans and robots have explored is the Moon. However, for many born after the 1970s, the manned moon flights are distant historical events. With the recent discovery that vast deposits of water ice may be present at the moon's poles, the possibility of future exploration and even industrialization is more likely than ever before.
ऐसे भी सही लगता है ये चश्मा तो भी बहुत अच्छा लगता है.
Once the sole territory of the United States and Russia, the moon has now been successfully visited by robot craft from Europe, and in the last few years, from the three Asian technology giants, Japan, India, and China. But the $30 million X Prize for the first non-government lunar robot lander is ensuring that a return to the moon will happen in the near future. The Chinese have also expressed interest in a manned landing, possibly in the next decade. United States plans for a return to the moon have been canceled. Instead, NASA is planning a manned landing on an asteroid. The Japanese spacecraft Hayabusa captured some microscopic samples of an asteroid and returned them to Earth in 2010. Beginning in mid-2011, the Dawn spacecraft orbited Vesta, the second largest of the asteroids found between Mars and Jupiter. Its results show that Vesta has remained virtually unchanged since its formation 4 billion years ago. Yet the varieties of features suggest that this tiny world has more in common with the larger planets than previously thought. Dawn is now en route to the largest asteroid, Ceres. Someday, mining asteroids could become an important source of minerals scarce on Earth. It has been estimated that the commercial value of a typical asteroid just a few kilometers across is around $80 trillion. That's enough to pay off the U.S. national debt 5 times over. Related to, but different from most asteroids, are comets. They are more volatile and release great amounts of gas and dust as they are warmed by the sun. The most well-known is Comet Halley, whose relatively short orbit brings it close to the sun every 76 years. So for its first return of the space age, Russia, Japan, and Europe sent robots to meet it. The most daring was the European Giotto craft. In March 1986, it got within 600 kilometers of the comet's nucleus. During this time, the 15-kilometer-wide comet was ejecting 3 tons of material each second from 3 major vents, mostly water and carbon monoxide. Giotto endured over 12,000 impacts from cometary debris until one violent impact knocked the craft off course and destroyed its camera. Since that time, a number of spacecraft have made more cautious approaches to less active comets. They have managed to collect some comet dust and even deliberately crash into a comet to release materials. The most difficult and dangerous comet mission since Giotto has been underway since 2004. In March of that year, the European Space Agency launched the Rosetta spacecraft, which will rendezvous with its cometary target in 2014. Excitingly, Rosetta carries a smaller robot explorer, Philae, which is due to actually land on the comet's nucleus in November of 2014. Explorations of asteroids and comets with their apparently ancient composition will hopefully tell us more about how the planets were formed over 4 billion years ago. More robots have been destroyed trying to explore Mars than any other planet. The Russians have been particularly unlucky. In 2011, their most sophisticated Mars robot got no further than Earth orbit. It had been designed to land on the surface of the Martian moon Phobos, a possible site for an early manned mission. Despite all the difficulties, there are many robotic explorers from the US and Europe at work. In 2012, the US successfully landed the largest and most sophisticated rover named Curiosity to begin a new era in Mars exploration and eventually allow the first manned Mars landings. Manned flights to the largest planet in our system, Jupiter, are unlikely for perhaps a century or more because of its dangerous radiation environment. Even robots need to be especially hardened to survive here. The Galileo spacecraft, which orbited the planet for several years, often lost data and even had electric arcing between some of its components. It's a deadly place for robots and humans alike. However, some form of life might exist nearby on Europa, one of Jupiter's giant moons. Its icy surface is believed to cover an ocean with more water than all of Earth's oceans combined. Europa will be the target of robot orbiters and landers between 2020 and 2030. Looking like a giant propeller, Juno uses new high-tech solar panels to generate electrical power. By the time sunlight reaches Jupiter, it is 25 times weaker than on Earth. Launched in 2011, Juno will enter orbit around Jupiter in 2016. It is expected to revolutionize our understanding of the atmosphere, environment, and origin of this giant planet.
Satellite.
At twice the distance of Jupiter, Saturn, second largest of the gas giants, presents its own challenges for explorers. Since 2004, Saturn has been orbited by one of the largest and most sophisticated robot explorers ever made. The size of a minibus, the Cassini spacecraft has been studying the giant planet and its 60-plus moons. Cassini's instruments have revealed Saturn's spectacular ring system to be amazingly complex and constantly changing.
Asteroid belt.
If they were around Earth, the rings would stretch almost a third of the way to the moon, yet they are only 10 meters thick.
ये शायद चाहता रिंग है ना वो.
These trillions of tiny ice particles are constantly being sculpted into different positions by the effects of moons both large and small.
Saturn.
One moon, Enceladus, is believed to be filling a ring with icy material ejected from water geysers on its surface. Enceladus and the giant moon Titan are the two most fascinating in Saturn's grid. In 1980, Voyager 1 sacrificed its chance to visit the more distant planets to close in on Titan, a moon bigger than the planet Mercury. Voyager's cameras found Titan's surface hidden by a dense atmosphere. But other instruments revealed that this atmosphere was largely nitrogen topped by dense hydrocarbon smog. This means Titan was like the Earth of 4 billion years ago, but frozen in interplanetary deep freeze, a prime target for Cassini. Not only could Cassini see through Titan's clouds with infrared and radar, but it carried a lander. In December 2005, the European Space Agency's Huygens craft spent over 2 hours drifting to the surface of Titan. Transmitted back to the Cassini mothership, its pictures were startling Earth-like views: rivers, mountains, coastlines. However, these are rivers of methane and mountains not of rock, but of rock-hard ice.
Satellite.
Huygens soft landed and sent back a panorama of its surroundings. This is a recreation of exactly what it saw: a floodplain covered in pebbles, rounded by a rushing torrent of methane hundreds of degrees below the freezing point of water. Yet this world could be a time capsule to transport us back to the birth of our planet and the first stirrings of life itself.
Saturn.
Another time capsule could be discovered when in July 2015, the New Horizons spacecraft encounters Pluto and Charon. After almost 10 years and over 5 billion kilometers traveled, this intrepid robot will have explored remote Pluto and its known moons. Demoted of its planetary status, this is one of the largest known of the icy worlds that haunt the outer reaches of our system.
Pluto.
What is it? An escaped moon of an outer planet? A giant comet? A dead ice-encrusted globe? Or perhaps the home of tenuous icy geysers? Beyond it lie perhaps billions of tiny frozen remnants of the early solar system that litter halfway to the nearest star. The nearer stars are the target of a different robot, which has been seeking planets orbiting other stars. By carefully studying how the light from stars change over time, it's possible to detect the presence and orbital movement of distant yet unseen worlds.
Okay, guys.
It's only one of many ways in which thousands of possible planets have been discovered orbiting other stars in our region of space. Some are single-planet systems, many are multi-planet, but planets there are in fantastic variety and numbers. As our advanced robots scout the heavens for signs of alien life, it's perhaps worth wondering if their robot explorers have yet spotted our little world. And threading its way through the darkness of space, could there be, already on its way, a robotic ambassador from a distant civilization located far in the dark depths of interstellar space?